In the two examples we just worked, we talked about average rate of change and the secant line. Those should be concepts that you've seen in a previous course, but a brief review is always helpful, especially because now what we want to do is build on those concepts to establish the idea of instantaneous rate of change and the tangent line. Before we get into those examples, we want to look at an interactive graph where we have a quadratic function graphed. We have two different points that we've selected, point A and point B, and we have the line, a straight line connecting those 2 points. So what we've done is constructed the secant line passing through points A and B. And then over on the left, you can see that I have this value h set equal to 3. That value of h is the difference between the x coordinates for the points that I've plotted. Our first point A has an x value of 1, and our second point B has an x value of 4, so that difference between would be 3. And what we're going to do to construct the tangent line from this secant line that we already have is take that value for h, the difference between our x values, and make that smaller and smaller. And we can see that our secant line moves as we do that. And what we want to do is get that value for h, the difference between our two coordinates, or our two x values, closer and closer to 0. As we get closer and closer to 0, we start to construct what we refer to as the tangent line. And if we could continue to do that, as that value for h gets infinitesimally small, infinitesimally close to 0, we would have the tangent line exactly. But that's what we want to think about when we talk about the tangent line. Again, we start with that idea of the secant line, just choosing any 2 points. We're still choosing 2 points, but we're making the distance between those points infinitesimally small, infinitesimally close to 0. In examples 3 and 4, we have examples of a curve graphed along with its tangent line. And we're also given this new notation, this new information. We would read this by saying f prime of -1. And that f prime notation is the derivative of our function f evaluated at -1. We haven't really talked about what the derivative is yet. We don't know how to construct that. We're just being given this piece of information that the derivative of the function being graphed at x equals -1, that derivative function has a value of -5. And that value of -5 is the instantaneous rate of change for our function at this point. The instantaneous rate of change is also the slope of that tangent line. So for this problem, since we're given that information, there's no work that we need to do. We know that the instantaneous rate of change for this function f at this given point is -5, because f prime of -1 is equal to -5. What that's telling us is that at this specific point that we have plotted, our function is decreasing at a rate of -5. Or one way to think of that is the slope of that equation is -5. Now we can construct the equation for the tangent line at this point, which will be very similar to what we did with constructing the equation for the secant line. We already have our slope of -5. So now we just need to identify the x and y values that that particular point passes through. We no longer have 2 points to consider, just a single point, which in this case is -1, 4. So we'll substitute those 2 values into our equation to give us 4 is equal to -5 times -1 plus b. -5 times -1 will give us +5, so we'll subtract 5 from both sides to get -1 is equal to b. Thus the equation for the tangent line at this point is y equals -5x minus 1. We'll use those ideas to look at one more example here, keeping in mind that what we have is the graph of the tangent line for this function. We've reduced the distance between those 2 points that we would have used to construct the secant line to nearly 0. And we're given this information again about the derivative of our function at x equals 1. We're told that the value of that derivative function is -1, which means that the slope of our tangent line, which is the instantaneous rate of change of our function, is -1. And then similarly, we can find the equation for the tangent line by identifying the point that we're passing through, which in this case is 1, 1. That means we'll add 1 to both sides to solve for b, and we'll get 2 is equal to b, giving us an equation for the tangent line of y equals -x plus 2.